for coming for the tea music day. Yeah, please take a seat. Thank you for coming to the tea music proposal day. It's an exciting program, and so first we will start it with some of the security and introduction. So might be wrong.
Good morning. Welcome to the Executive Conference Center. My name is Jennifer Howell, and I am the manager here. So before you get started, I'd like to just make a few announcements in regarding to the facility. So first, this meeting is going to be held at an unclassified level, so please keep the conversation as such. This is also being broadcast, so if you're a speaker, we ask you to please stay here at the podium so you are mic'd. There shouldn't be any questions taken from the group. You are given index cards that you'll be writing them on and handing them to Kalea at the front desk. If something is said in the room, we just ask the speaker to please repeat it so those on the broadcast can hear. You were issued a badge when you arrived. We ask you to please wear that so it's visible. That way we don't ask you to leave the room if we don't see that on you. We do expect this room to be at full capacity, so please, if you see somebody wandering and looking for a spot and you have an empty seat, please wave them in. And as you are here during the one-on-one sessions and you're waiting around, we do have Wi-Fi, and that is posted on the room here on the front and back of the walls. We also have business cards at the registration desk that you can have to refer to the password and the Wi-Fi that's available. If you are lucky enough to have one of the seats here with a table, there are power strips located in the front cover. So please use those. And if you're in the back of the room and you need power, please, there are outlets on the floor. Just watch how you stretch the line so we don't trip anybody. Restrooms. Restrooms are not located directly here in our facility. You have to leave the door in which you came, make that immediate left, and then a right, and you'll find the restrooms. Beverages, we have all-day beverages that are permitted in the room, so please bring them in. If you don't have a table in front of you, I ask you to try to keep a lid on it. If you don't, then please don't set anything on the floor that's full to avoid spills. There are trash cans located in the back of the room, as well as out in the foyer. If you have any meeting material that needs to be thrown away, please just leave that with Kalea at the desk, and that will get disposed of properly. Even though this is an unclassified meeting here in the room, and I know we're broadcasting this, but we do ask not to use your cell phones to record or take pictures. During the one-on-one sessions this afternoon, those will take place on our second floor. So rather than go to the second floor directly, please see Kalea at the registration desk and she'll escort you down. Otherwise, you are permitted to stay here in the facility and use our Wi-Fi desks and the beverage service. We will also provide afternoon snack service. There'll be a basket out there during the lunch break time. And if there is an emergency, the alarms will go off. We do ask you to depart through the back doors of the facility and exit the door in which you came. There is one more door in the very back to my right. That takes you right out to the hall. There is a stairwell right immediately there. You'll have to take 3 flights down, and we'll exit the front door, and then you'll head down Randolph. So you'll go away from DARPA, down Randolph, and make that right-hand turn on 9th Street, and that's where we'll rally, and we'll just make sure everybody got out. If you can't make those stairs, please stay put. I will check the room, and we'll make sure that you get to a safe location. And I will now turn over to Ron. Thank you.
Thank you, Jennifer. Jennifer really hit many of the points that we would normally cover. One thing that I would add is pending or following the receipt of your proposals. At that time, it may be determined that a CUI guide might be established and included in the BAA to outline any. This is unclassified, of course, but just to define and outline any unclassified information that we would want to control, critical technologies, for any possible space or military applications. But again, that would when it's determined, that may or may not accompany the BAA when it goes out and it's released, and you'll find out more about the BAA today and later. So at that time, at this time, I guess I'll just turn it over. Thank you.
All right, thanks everyone for coming. I know it's early for the West Coast folks and early for some of the East Coast folks too, but this is going to be, not this one, okay. Got it. All right, so this should be a fun day. This is our core group. I see a lot of friendly faces, people who have done incredible work in this area of national security and electronics, and I think we're really excited to have someone like YK sort of lead the charge in this next chapter. I think it's pretty rare to have someone who's a National Academy member, comfortable life at Bell Labs, leading telecom charge, that's impacting the entire globe, raise his hand and say, I actually want to focus on national security for this next chapter of my career. And I think it's a uniquely American. Yeah, all good.
Sorry about that.
That it's a uniquely American trait to have people want to join the government temporarily to provide this type of leadership. So I think we've got the right leadership. We're resourcing it. We think at a high level, all right, to choose sort of this intersection of RF and digital processing, right, to make this next leap. So this is part of the ERI initiative, and many people have seen this before, but I will repeat it and then maybe put it in context to this program. Right? Electronics has been paced by Moore's Law for the last 50 years. We're at an interesting inflection point. This is specifically a chart about digital processing, but we're talking about moving from advancement coming from just the digital processing piece to something else, right? If you take a look at that y-axis, right, we're saying that the traditional metrics of advancement are going to be replaced and by something else, which we don't necessarily know what that is, and it's also going to be application dependent. We believe that that's something else, even though it's going to refine itself over the next 5 to 10 years, is going to be more domain specific, and one of those domains is the RF domain, and one of those domains is the analog domain, the analog digital boundary. Right? So as we move into this more specialized, secure, and heavily automated electronics industry, we think that it's very important in the RF domain, where the military needs have actually driven and paced technology for many years, that we maintain leadership in that specific area. So let me step back, and again, some of you have seen this, but not everyone has, but kind of where this fits in the big picture of where the office is heading and where we're trying to lead the country. If you say that we're trying to create a more specialized, secure, and heavily automated electronics industry, the university research that we've done has been something we're proud of sponsoring for years. What's a little bit different is we're asking for the universities to pair directly with our industry base, both commercial and DoD, to make sure that we're not ending up just in a paper that's free for the rest of the world to capitalize on. So how do we take that university and build programs that allow for partnerships to advance that work in a more direct manner than just leaving it at the paper. The paper is the start of a journey, right, not the end of the journey. So we're going to continue and actually increased how much we're funding that direct university layer, but then added these series of programs and these bins of materials, architectures, and design. So in the materials bin, it started with the CHIPS program, and we asked a pretty simple question: what if the last 50 years, right, stopped being the vector of progress and we just blew it up? Right? As Arthi saw it and laughed, she said, "But this is, you're investing in the thing, right, that is opposite of anything I would have invested in as a VC." Right? Everything was about how to do fabless design in a monolithic way, right, for the last at least 20 years of VC funding. And we said, well, what if we just exploded that? And said, heterogeneous integration is now the vector of success, and that makes things, I think, more interesting, right? Whether this is the future or not, I think is a story yet to be told. I can tell you it's a more interesting future because you don't have the tyranny of monolithic design, right, where bigger is better and access is harder and innovation is harder. You now explode it, so you can now think of kind of weird stuff, right, like 3D SOC, which I know is a very hard concept where you've got carbon nanotubes and ReRAM working together, so you've got logic and memory fully stacked. So if you've got locality matters for your algorithm, locality is what it'll maximize, even though the performance of each of the memory and the transistor might not be as good. Overall, for certain algorithms, it's proven to actually be better than optimized memory and optimized processing that are disconnected. So that's kind of the basis of 3D SOC. Whether this is the right direction to go, I think it's a good example of what heterogeneous integration does for being able to unleash materials, right, to maintain progress in a heterogeneous environment. We're also then looking at different memory structures and memory side processing and how to use the memory as either in an analog way or unique digital ways to do processing more local to that memory. For example, the Illinois team working with Raytheon and Global Foundries is looking at how to speed up different learning algorithms by using deep in-memory architectures. So that's really, what we did announce last year. And if you step back, it's kind of in that memory and processing space. So you've got chips, which allows you to add different materials into the mix so that you're not only trying to invent at the 7 nanometer node. You then add in Frank and 3D SOC as memory and processing. And then for phase 2, all right, we announced our first program in phase 2, which is called PIPES. And that's photonics and packaging. So how do you take that photonic reach and go all the way into the package, which really means you got to get to a sub petajoule per bit, really looking at 100 femtojoule per bit. So it starts to make sense to have optics as close, either chip to chip, but really focused on this program package to package. So I just have an example of a concept here. It's from the POEM program. So we've looked at this in the past, but we've never gotten to that or where we need to really get the energy so that the optics is replacing copper at that intimate level. And we think pipes will get us there. And that's how you interface off of this heterogeneous mix, right? Whether it's monolithic or heterogeneous, it still will apply. This is how you can get data around between chips within the system. So that was kind of stage 1 for phase 2. And then we added T-Music. Right? So pipes was earlier in the year. Now we have T-Music. And T-Music asks a different question. Right? How do you get systems out, or information out of your system, not just between different chips? Right? How do you interface with the real world? Right? For some amount of time, we're still going to live in an analog world, and so you're going to have an interface to that world. And SIGI is a very good way to do that. And but I was a program manager here, and an example of a program we did was RF FPGA, where we tried to maximize flexibility of an RF front end. And a lot of the performers bounced between SIGI and CMOS, and let's say you had a digital PLL design and you had the tank circuit, you wanted a high voltage, you wanted SIGI there, but then you'd have all the inefficiencies of the digital feedback path in an older CMOS node, and you'd switch to the CMOS and you'd have lower performance. And it was either you wanted to be efficient in the digital or high performance in the RF, and we kept bouncing back and forth, and there was no optimal solution. So in team music, we're kind of trying to have our cake and eat it too, which is advanced CMOS processing with and advancements in the silicon germanium. Can we maintain world leadership in silicon germanium within the shores of this country, but then also pair that somehow with the advanced CMOS, so you can do a lot of the hardcore processing local to where that RF analog to digital interface is going to be. So YK is going to dig into that a lot deeper, but you can kind of see where that fits in that overall mixture of investments over the last year. So now we've got pipes and T music. The other thing that you may have seen is gaps. So that's really not the subject for today, but give you kind of where the rest of ERI is headed. GAPS is a program for guaranteeing where our data resides within any one design. So if I go to DARPA, I know what's classified and what's not because I know which room I'm allowed to have certain conversations in. When I put my medical records online, right, I just have a faith-based initiative that there's some sort of protection being applied to my data. There's hypervisors, there's all sorts of concepts out there, but they've all been proven to be faulty in various ways. So are there ways to have guaranteed physical access separation of critical information? In the commercial world, that's privacy, right? How do we guarantee privacy of information? In the military, that's classification. How do you do multi-tier classification across a complex design? And so that's really where GAPS is heading. How do you do guaranteed physical assurance of where the bits of information are in any one design or any one system? So as we move forward, we've also announced the Defense Applications BAA. We had a industry day to collect sort of feedback on what that looks like, and so that's still yet to be on the street, but announced. And that is, how do we take all of this type of work between the materials, architectures, and design and work to demonstrate it impacts real military systems, right? Systems that actually are in need of advanced electronics, and how do you take these sort of basic concepts and transition them over this 2025, 2030 time horizon so that we aren't leaving them as good things that impact the commercial sector but not directly impacting the DoD. So that's where we're at with phase 2. We're still going to announce more throughout the winter, but you get a sense of where we're heading and where T-Music fits into the bigger picture. The bin in which pipes and T-Music fit is called differentiated access. The concept is to advance the state of the art of the research while also ensuring access from the DoD partners of advanced capabilities, right? So there's a little bit of a development aspect, development with access, with research on top of that, right? Paired so that you get the user base access to novel technology while you're making sure that that next generation is taken care of. And YK will kind of walk through the different TAs and how you're trying to get both of those done simultaneously. All right, any questions? Dev.
So you show the foundation as university research.
Yeah.
Broader than that, right? I mean, there's government labs, research labs.
Yep. So the foundation, I'm in regards to the RI programs, there's everybody is involved. That is really code for the JUMP program. We're putting $200 million into a collaboration with industry on the foundation of the next generation human resource development in universities. And so that is why that's specifically called out as university, because that is where the vast majority of that money is going initially. Of course, there's good foundational research in all aspects of the development cycle. So thank you for pointing that out, because I would agree with that as well. All right, any other questions on where we're heading? And if not, we'll pass over to YK.
Yeah, thank you, Bill, and thank you, Bill, for calling me up about a year and a half ago. See if you want to join the exciting program called ERI. So I hesitated a little bit, so I missed last year's call. So, but I have a privilege to join DARPA to start this program. So, so I think let me try that's a different file. Yes. All right. Okay. Good. All right. Wait to reset. Yes. All right. Thank you. Yeah. So I joined about a year and ago, and at that time, my group was working on finish up the 5G things and Nokia Bell Lab. So we were actually looking at the 6 gig, right? So, and a lot of technology we try to develop is starting to see how we're going to support the 6 gig wireless infrastructure. And if we look around, a lot of semiconductor technology is not quite up there yet, but there are a lot of investment in Europe, which our group has been using, and which wasn't much doing in the US. So that's why for the past year, I've been talking to a lot of our industry and academic folks, and also within DARPA to see how can we increase the capability for our wireless interface to give us much better capability for the next decade for 6 gig, right? So 5G just start deploying, but we have to look into the future. So for the T-Music, basically we try to establish a semiconductor infrastructure or platform to give us higher capacity and also more speed and latency for both commercial and also particularly for disruptive DoD applications. So I'll just give you some of the high program overview, and the BAA was published last Thursday, so yeah, feel free to review it online. And let's just give you some high-level background on how the program will be structured and what our goal will be. As Bill mentioned, and we are living in the real physical world, but a lot of the digital intelligence are in the digital world. So if you can see basically in the digital world on the semiconductor electronic side, you can see based on the Moore's law, and you have been going up in terms of the density in the transistor count, the vertical axis, and over the year on the left-hand side slide. Pretty much follow the Moore's law, but kind of saturated a little bit in the past 5 years or 6 years or so. So, but on the other hand, if you look at transistor speed, which is really critical for analog applications, the vertical axis on the right-hand side is transistor cutoff frequency over the horizontal years. As you can see, the CMOS transistor speed scale up quite well with reduced gate geometry up to about 32 nanometer. However, people are really try to push more transistor on the same chip, and then the leakage current and the voltage swing will give you a lot of power consumption. So in order to reduce the power consumption or density on the logics, people go into the FinFET structure and try to reduce some of the leakage and reduce the voltage swing, which is great for the digital integration. However, they will give you the expense of the analog performance. Basically, like a FinFET structure, you can control the channel in a very short gate on the side, and that will reduce the short channel leakage and reduce the voltage swing. However, they reduce also the current driving capability. So in order to swing the parasitics, you have to pair multiple things together, and the parallel capacitance will reduce the speed. So basically, intrinsic silicon speed is still pretty fast, but just the external parasitics of the architecture of the device really slow it down. So as you scale more, you can increase the density, but doesn't help you in terms of the transistor speed. So you can do that in the digital world by parallelism, but however, in analog, you really cannot do it. So then we really like to look into the transistor speed over the density trade-off, right? So you can see on the silicon CMOS, basically, as I mentioned before, it's kind of saturated. And also the most advanced CMOS node, as marked in the red, is really offshore, right? So basically onshore, we barely get it into 14 nanometer in the onshore, but in the offshore, maybe Intel get a 10 nanometer, but a lot of fab are really offshore. So and the speed wasn't really as good. But on the other hand, if we look at other devices like silicon bipolar, they will give you pretty good speed even at very large transistor geometry, because its transport is really vertical direction. So so in the European, basically, they are looking into a lot of 5G backhaul, and even for 6G, they invest quite a bit in the past 10 years, and basically DARPA 5, DARPA 7. DARPA 5 means 500 gigahertz transistor, and DARPA 7 means 700 gigahertz. Now, they started Toronto, which 1 terahertz transistor go about a year ago. So those are 5-year programs. So basically, they have been invested, but somehow their CMOS in the integration platform still at 130 nanometer, or the ST at 55 nanometer. So what we try to do is basically in this program, in the first technical area, in Tier 1A and the B, is really trying to bring the onshore foundry capability to be twice of the speed of the competition, and also the current status, and also integrate advanced CMOS inside the platform. So in that case, you can expand a lot of functionality inside the SoC. So for example, if you want to integrate the RF front end together with converter and with some calibration, and maybe with the machine learning capability on the same chip, in that case, you will need a very fast transistor, very efficient in the RF front end, together with integration of very advanced CMOS node to give you low power processing. So you can put all the things in your cell phone, for example, or the DOD sensors to give you extra performance. So we also need to look beyond that. So also on the Tier 2, we really like to build the silicon-based technology up to terahertz transistor. We know the 3.5 technology can give you terahertz performance. However, the integration level is really to the left-hand side, pretty much off the chart, right? So in that case, we really like to push the technology in the silicon platform with the advanced lithography, which we believe it can be done. So that's why we challenge the community to able to look into this and push the technology to the world-class performance. So that's what the high-level goal for the T-Music program It's pretty much based on the wafer scale, onshore capability, and to build out of both foundry and advanced device technology. So what this technology will bring to us, so basically with higher, faster transistors, then you will be able to do very broadband RF front end. So for example, the RF front end broadband bandwidth is really limited by the cutoff frequency, and the gain is the operating frequency to cutoff frequency ratio. So in that case, if you push the cutoff frequency higher, you will have much higher gain, even at the low operating frequency. So that will give you a lot of better efficiency. You don't need too many stages to build enough gain to amplify, because fewer stage with higher fast transistor we're able to do that, will reduce the power consumption. And then also the fast transistor will give you much better input bandwidth of the converter, and together with CMOS, then you will be able to do very high dynamic range ADC and the DAC converters, and that will be critical for many analog application for both RF, optic, and other sensors. So the other thing is a precision oscillator. So a lot of critical application in the sensor or the wireless, if you push up the data rate or the frequency, and particularly for some of the sensor like a Doppler application, if you try to detect very slow moving object, like people riding on bicycle or walking, and your automotive car try to detect them, and if your Doppler doesn't give you fast response, then the phase noise will obscure the return signal. So it's very critical to have very close-in phase noise, then that will give you more resolution in the moving target. So we are not just looking at static target, we can use for many different applications. So the T-Music is trying to use this technology to enable from both RF side all the way down to the baseband and conversion and the processing. So in this case, we can enable many applications on the DoD side. For example, you can implement the highly integrated millimeter wave or broadband phase array with a much wider bandwidth with lower power consumption, because your transistor is more efficient and a higher frequency. And then also you can do a high resolution converters, and typically you might need a phase array with multiple elements, and not just to do direction beamforming, but also to reduce the uncorrelated noise from each receiving element, because your signal is coherent across all the elements. But however, if each individual element is very noisy, you need many of them to quite average it down. But if you can have very low noise converter, you don't need so many elements to do it. So in that case, you can significantly simplify the phase array architecture, and to reduce the size and the power consumption as well. So another thing is, again, the phase noise, and also critical for a lot of moving target detection. So we try to, instead of not just building the foundry capability, we like to basically add the some of the application cases together with the foundry development in the TA1. So in that case, the foundry will develop a very robust process in the mixed signal mode application. It's not just fast transistor, it's not just low noise, but rather a balanced technology which can be used for all these three different basic building blocks, which kind of constitute all the RF and analog electronics. So for the other commercial application, as I mentioned, we are going to deploy the 5G commercially this year, toward the end of this year. So you will get a 1 gigabit on your cell phone, on the 5G phone or dongles probably this year. And the people are trying to do 1 gigabit, the millimeter wave to the home for the 5G for the first case, so they don't have to dig the ground to put in the fiber. So they are big application at a 28 gigahertz or 39 gigahertz. But then the backbone operation has to collect all your cell phone data and the backhaul to the central station, and then each base station have 10 user, if not 20. Then you are easily going to 100 gigabit backbone traffic for 5G, and which can be done at the 90 gigahertz range for the 5G. But however, if you look at the 6 gig, which will be people start thinking next year, usually wireless every 10 years, you have one generation. So people are planning, particularly in Europe, looking to the 6 gig. And we have to look at what kind of backhaul capability, and also for your stationary indoor Wi-Fi, can you cover 10, 20 gigabit data at a very low cost? And that's really trigger a lot of interest in the commercial world for the RF or millimeter wave SoC. In that case, you cannot use discrete element and then piece them together with such high data rate and a high frequency. Just the cost, you can do it, but the cost and the power consumption will prohibit many of the large volume applications. So there are a lot of commercial drivers to push the RF SoC technology as well. So I just got a little bit more detail on the program structure. So the program was structured in 3 phases over 48 months, and the first 2 months is about 18 months, and the last phase about 12 months. So we were separated into 2 technical areas. TA1 is mainly focused on the foundry platform development, both on the foundry technology and the TA1A, and the TA1B is try to work on the advanced circuit things together with TA1A partner, and to co-develop the platform. So in that case, the TA1B will work with TA1A performers and to develop the test cell and in the PCM, and also the critical mixed mode things they were introduced in the TA1 test iterations to make sure the device you develop will be meet their circuit performance goal. Then for TA1B, we will pick the 3 critical building blocks to make sure the developed technology and will be meeting these performance metrics. And while we try to look at the new circuit architecture and to fully capitalize the high-speed transistor developed by TA1A. So there are a lot of collaboration between TA1A and the TA1B, which I will substantiate later. And then TA2, as I mentioned before, we look into more foundational device development based on the silicon, existing silicon technology. As you know, the silicon technology can go to the nanometric lithography and with high yield. So can we use this technology to improve the device performance to terahertz compared to the 3.5 and the other technologies? So the TA1A will be funded by 6.3, about $55 million. Mainly will be inside TA1A for foundry operation. They are doing the process development in the foundry platform and also provide the MPW for the design for the TA1B for the test cell and the circuits. So TA2 will be 6.2 funding, about $15 million. So the objective of TA1A is mainly to develop an onshore foundry platform. The key metrics is really to hope double the transistor performance by factor 2 toward the end of program in the production environment, and also integrate together with the CMOS below the 22 nanometer. So there are certain challenges. So definitely, how can we do the lateral scaling to increase device performance, and how can we integrate with advanced CMOS? And so those are very critical process development inside the foundry. But there are certain innovations can be accomplished. As for example, if we look into the by CMOS platform, the bipolar has very thick box. to reduce the parasitics to get a high-speed transistors. And the same box can be used for the SOI platform in the CMOS, which you can reduce your substrate leakage and also increase the performance of the device and reduce also the RF crosstalk with the SOI layer. So in that case, we like to see the integration of these high-speed transistors on the same CMOS kind of wafer scale platform. So then accompanied to the process development, so we also invite the community to look into the how to capitalize the advanced device technology to look at the new innovative architecture and to establish the critical building blocks in the RF gain section and the converters and also the digital cell. So ultimately, we like to target the final performance, but as the process are evolving, so we like to look into the different architecture, mainly focus on the building block to enable those critical capability and how to reduce the phase noise in the phase lock loop synthesizer and to be 20 dB less phase noise than previous technologies generation. And also how do we do the wideband converter to give you 3-4 extra effective number of bits over much wider bandwidth provided by the technology. So we will go into the matrix more. And definitely we like to see the digital CMOS technology will give us much higher scalar capability to do that. So the Tier 1B performer is basically will be designing their circuits and also including some of the basic building block matrix circuits onto the MPW provided by the phase 1A and then to demonstrate the capability. So certainly you are welcome to design your own particular applications on the same wafer if we have enough space on the reticle, but definitely there will be exciting area to explore. So then the Tier 1 matrix, as you can see for the phase 1, is basically for the Tier 1A, is we are trying to develop the transistor technology from the existing platform and to integrate it with advanced CMOS up to 90 nanometer. And then in the meantime, they will iterate the transistor technology to increase the cutoff frequency up to a higher level and to 350 to 500 gigahertz range and in the production environment. And in the meantime, they will provide the current generation, the CG by CMOS technology or CMOS technology to the Tier 1B platform, and for them to design the 3 example building block circuits plus whatever other circuit they are willing to do. So we will have some the demo circuit with a phase lock loop oscillator to get some the phase closing phase noise requirement, and eventually at the end of phase 3, we would like to achieve max 120 dB kind of phase noise floor, which is almost 20 dB beyond the current state of the art with the current generation of the technology. So these are critical as we will need to work together with Tier 1A foundry partner to reduce the phase noise or the crossing 1f noise in particular in the transistors and to achieve this kind of capability. And there are also circuit innovation. How can you use different architecture to reduce the crossing phase noise? So we hope the collaborative effort between the Tier 1A and the Tier 1B performer will be able to give us unique capability, which is kind of challenging, but we believe it can be done. It's not a break the physics limit yet, so which is good. So for the ADC, we also like to push the performance. Initially, we started with a relatively existing platform of the process and to build a 1 giga sample, but we like to see 16 bits of ENAP resolution. So certainly that's a 1 gigahertz per second sampling rate. So certainly they are the timing jitter requirement, but there's oversampling things you can play. So ideally, we would like to see 100 megahertz to 200 megahertz bandwidth, so we can leverage the oversampling ratio to overcome some of the jitter requirement. But in the meantime, you can use this opportunity to establish the sub ADC at a low frequency for your future phase 2, phase 3 goal, to do some of the pipeline time interleave or the MPass kind of architecture. So that's something, that's why we set some of the metrics in the phase 1. But ultimately, in your proposal, you should like to look into how can we optimize the new architecture with the advanced transistor to reach the final phase goal. So that's important to keep that in mind. So ultimately, we would like to have at 100 gigasample per second with 8 ENOPs. So typically, you might need 10 bits or 12 mechanical bits to give you 8 ENOP. We'll give you 50 gigahertz instantaneous bandwidth. That's broadband bandwidth. And so typically, people are doing that in the commercial world. For the fiber optics, you can get 100 gigasample per second, get 40 gigahertz kind of bandwidth, but only get 6 bits. So with the better transistor technology, we believe we should be able to push to 8 effective bits of the 50 gigahertz instantaneous bandwidth. It's not a narrowband bandwidth you scan over the 50 gigahertz, the whole 50 gigahertz Nyquist band. Okay, so the last demo circuit is frequency divider. So basically, we try to demonstrate the digital circuit up to 200 gigahertz based on the transistor performance we have. So there'll be the TA1 matrix. So the TA2 is really focused on the TA terahertz devices on the silicon platform. So so it's important that we look at the existing silicon fabrication toolkit. So we will be able to capitalize the silicon platform with the fine line lithography and the alignment tolerance to give you better transistor performance, which is beyond what the typical Moore's law try to increase the density and reduce power consumption. So in that case, there are certain examples has been demonstrated before. For example, with the new ferroelectric dielectric layer in the high-K gate stack. So potentially you can, with a very small voltage swing, to give you much larger charge control. So in that case, it's effectively negative charge capacitor FET. That's what Professor Salahuddin and Chen-Ming Hu at Berkeley was called. But actually still positive capacitor, but reduce the capacitance. But they are able to predict to achieve about more than 1 terahertz transistor by reduce the transistor extrinsic transistor capacitance down by swing a large amount of charge. So your GMC ratio, which is related to the charge to the capacitance ratio, can be significantly improved up to beyond 1 terahertz when you reduce the gate length below 20 nanometer. So separately, IBM group by Technin and company demonstrated almost 8 years ago, they can use the advanced CMOS at 30 nanometer kind of thing, FET structure. Then they can build a lateral bipolar transistor, because then they can use some kind of doping implant to reduce the base width from 30 nanometer mechanic lithography down to 10 nanometer. So they already demonstrated 1.2 terahertz Fmax with 400 gigahertz FT already. So we can try to utilize this capability and the similar or different or even better architecture to give us 2 terahertz transistors. So we believe it should be able to be done in the silicon platform, and then we need further development on it. So the TA2 matrix is mainly on the device development, so the goal is toward the end we will push to 1 terahertz in both FT and the Fmax with innovative material and device topology to achieve it. So then it's not just single transistor you develop. I get a whole 12-inch wafer. I only have one transistor working, which is not good thing. So we like to see some kind of benchmark circuit which you can show that at least up to 100-ish transistors, you can have a good yield out of these high-performance devices. So we put a divide by 4 prescaler, and hopefully we will be able to achieve 400 gigahertz prescaling speed at the end of phase, end of program. So the program schedule, as I mentioned before, is basically in about 3 phases, and each phase will be phase 1, phase 2 will be 18 months, and phase 3 will be 12 months. So as you can see in the TA1, we have TA1A to develop the foundry technology while providing the existing the previous generation technology to the TA1B performance to design the advanced device circuitries. So the phase 1, they will start release the PDK from TA1A from the existing generation to the TA1B to provide the design, and then doing the fabrication, while the TA1A was doing the short loop device development to prepare the PDK2 for the next generation. So at the beginning of the phase 2, then they will release the PDK to the TA1B to start the design and to do fabrication, then to demonstrate the matrix toward the end of phase 2. And the same thing happened for the phase 3. And they will prepare the phase 3 PDK during the phase 2 by TA1A foundry, while the TA1B circuit people will provide the input in the test cell and the PCM testing elements to make sure some of the phase noise and some of the other device property will be covered by the technology development. So those are iterative process. It's kind of pipeline along the 3 phases. I will have a more detailed charts later to see how to do that. So typically, I assume each MPW run is about 6 months iteration from the tape-in. So I think it's pretty good for the existing foundry capability. And the short loop is typically about 3 to 4 months per iteration. So it will show up in the later chart. For TA2, it's basically the similar 3 phases, as you can see. So then for the end, we will have the matrix. We will meet the matrix. So the DARPA provide the element, and also you have your own internal matrix and to see what kind of phase noise goal you would like to achieve, or some of the circuit performance you would like to perform. But we just provide some exemplified metrics on the program level. But you are very welcome to define your performance-based metrics as well. So some of the test circuits will be delivered to FRL, and they will provide some of the bench testing for you. To collaborate with you on that part. So let's get a little bit more detail in terms of the kind of Gantt chart-like schedule. So basically, as you can see from the TA1A, so basically they will provide some of the short loop on the leftmost column for about 2-3 short loop iteration to develop the next generation technology for the next phase. And while in the meantime, TA1A will provide the MPW from the existing manufacturing platform to the TA1B to design their super duper circuits and the new architecture. And so basically you can see the PDK release under the TA1A will be PDK 0, while they are preparing the TA1 PDK 0+1, which they will solicit the input from the Tier 1B performers. For example, how to test phase noise, how to test terahertz 100 gigahertz transistor, the calibration, and those things. And you are welcome to incorporate with Tier 1A performer from the Tier 1B designers. So same thing for Tier 1B. So once they got the PDK, they will start the design iteration, probably within about 4 or 5 months, and then they will tape in. Then they have a cycle time about 6 months for the MPW, and hopefully will come out. We have enough time at 2-3 months for testing and getting the report. So it will be good for both phase 1 and the phase 2 for both Tier 1A and the Tier 1B performance. For Tier 2 is really more short loop development on the right-hand side columns. It's pretty self-explanatory. So that'll be part of in the BAA. You are welcome to take a more deeper look. And for the phase 3, it's going to be shortened. We expect the technology relatively well established. So we will publish the PDK much earlier on, and then the short loop is still keep about the similar cycle time, about 5 months each, and to get enough results. So the design will be a little bit more on the fine-tune stage. So the design cycle will be shortened by a couple months at the phase 3. So that's pretty much the schedule. And so I think our contracting officer, Michael Blackstone, will give us a bit more detail on the contracting issue. I just provide you some of the technology aspect of the program. And there are certain evaluation criteria. So it's important you listen to Michael's description, because there are a lot of collaboration between Tier 1A and the Tier 1B. And each proposal should be stay alone for either Tier 1A or Tier 1B or Tier 2. You cannot cover multiple TAs, but you can submit multiple proposals independently to different TAs. So just a quick reminder to important BAA day. So the abstract, we will have an abstract cycle will be due to provide you a quick feedback. The due date will be 25th, and there'll be FAQ submission deadline on the 18th, and the proposal due date will be March 12th. And then we expect the through the selection and the contracting, the program should be started in August timeframe. So we will have the questions for sure. So please grab one of the index card and in the back, and then write it down, then give to Kelly and at the front. Then we can collect and answer you after Michael's presentation. All right, Michael.
Unplug and replug the HDMI.
All right, good morning. My name is Michael Blackstone. I'm one of the contracting officers that works out of DARPA's internal contracting shop. Spend my days primarily supporting the MTO office and also running a division that has one other technology office as well. So I'm just going to run through some procedural issues. They're not as exciting as what YK just went through, but they can be just as important. I'll start with the end in mind. They're important because you can have the best idea in the world, but it doesn't matter if you don't get it to us on time and you don't get it to us in a way that's compliant with the BAA. So the number one point to keep in mind is to read that BAA and make sure you actually follow it. Sounds simple, but there usually are a couple of folks every time we cycle through one of these BAAs that fail to do that, and it gets them into trouble, and it frustrates them, and I don't want to see PIs frustrated when you spent time writing proposals. So, a little bit of the legal stuff to start off with. These proposer day events are good. It allows you to get into the program manager's head, understand sort of what's behind the program, the metrics, and the details that are in the BAA that you're going to read through on your own. But at the end of the day, no matter what we say here, even what you see in our frequently asked questions list, that's all good information to help you point north, but what counts is what's in the BAA. So what you're going to write your proposal to is solely what's in that solicitation, and what we're going to do our source selection or evaluation on is based on what's in our BAA as well and what's in your proposal. So please keep that in mind. The fact will go out throughout the entire time that the BAA is active. So we'll try to keep questions and answers there for you guys to see. If we happen to answer something that is going to cross the line and require us to change something in the BAA, we'll usually tell you in the answer, hey, keep an eye out. This is going to result in an amendment that goes out. And then you just guys have to keep an eye out to make sure it actually gets into that BAA. We don't try to trip you up. We don't tell you that in the FAQ and then not do it, but just make sure, once again, you're driving your eyes towards the BAA. The last point, just for anyone who's sort of representing a new company, maybe a non-traditional, new to doing business with the government. At the end of the day, the only person in the government that can commit the government to direct you is going to be the contracting officer. So if you happen to get a letter at the end of this process that you've been selected, hold tight. Don't do anything. It's that contracting officer that's going to be telling you what to do and when to do it. So the little bit on the BAA process. Definitely, if you've ever worked with other agencies, it's different than an RFP process. It's a little looser, a little more flexible. Right, the B in broad actually means something. So we don't write requirements in these types of solicitations. What we lay out in that solicitation is a problem set. And then what you guys are going to do in your proposals is then define a solution set. So you're going to do that through your technical proposal, but you're also going to lay out tasks in your statement of work, and that statement of work will find its way into the resulting award instrument, whether that's a contract or an OT or anything else. We'll make sure that that information finds its way to that award instrument. So one of the advantages of the broad agency announcement is that we can use different types, besides having multiple performers, multiple selections, we can use multiple types of instruments. So for this particular BAA, we have 3 TAs. So for TA 1A and TA 1B, we could use procurement contracts or other transactions, and that's primarily driven by the funding type that you heard YK talk about. It's up on my slide. So that is funded with 6-3 funding. So as the university folks know, that means that is advanced technology development funding. It's not fundamental. So at every tier, prime and all the way down, that is restricted research. So that's why those instruments are tracking to that funding type. For TA2, different type of scope, different type of money. It's 6-2 funded, so that means all of the instrument types are actually up for grabs. You can propose to any of them based on what you want to do and the type of performer that you are. That's procurement contract, other transaction, grant, or cooperative agreement. Once again, 6-2 funded, so that means the folks that are university performers, whatever tier they happen to be sitting at, prime or sub, that means their work could be classified as fundamental. 6-2 funded work, if you happen to be at either tier a for-profit performer, that means that your work would be restricted research. So on the bottom half of the slide, we just go through a scientific review process for all of our BAAs. If you've worked with us, it's pretty much the same thing. And you saw the evaluation factors for this BAA. We kept it to a minimum, just the basic 3, to keep things kind of easy. So with the BAAs, we can select all, some, or none. Obviously, we don't want to select none. That doesn't really get us anywhere. The middle bullet is important with the BAA. We can slice and dice. So no matter how you propose to that particular TA, if YK and team sees that there's only a certain strength in 3 or 4 different things that you want to do, in one thing that you want to do, that may be all that you get selected for. So the BAAs allow us the flexibility of being able to slice things up. So don't be surprised if you get a selection letter. It's a good thing. You got a letter. You may be a little bit of a downer if you've noticed that it's a partial select letter. If that's the case, and I'll talk about it a little bit later, we'll contact you after that letter goes out, and we'll walk through what that partial means and give you a chance to revise your proposal. And then, of course, we always set up our programs so that our out phases, like phase 2, phase 3 in this program, are set up as options. We can also set up other tasks that we see that maybe we're not necessarily convinced of, that maybe are more risk reduction based. We can set those up as options as well, even if you haven't proposed them as such. So, timeline, you saw some of this in YK slides, so I just kind of put this up here. The things on the right-hand side with the brackets are in red. Those are sort of the amounts of time that you guys have to worry about in terms of things that you have to prepare for us as proposers. So from when the BA is released to when your abstracts are due, you have 21 days to get those abstracts to us. Then there's 29 days after the abstract letter goes out to when you have to write your proposals. So those are the two things you kind of have to worry about. We'll try to shave a little bit of time off our 17 days to review the abstracts to try to give you a full 30. I'm a big fan of going with 30 days if I can, but we'll try to keep it as close to that as we possibly can. Then down below that, from step 6 on, now the proposal's in, we're doing our source selection process. That typically takes us 45 days-ish, depending on how many proposals we get in and kind of what they look like. Those are the steps that you would normally see us kind of going through. Somewhere around 26th April, hopefully, you'll get a letter. It'll tell you whether you've been selected, partially selected, or not selected at all. Once you receive that letter, if you've been selected or partially selected, there's a little paperwork that we do in-house. We set up the informal feedback sessions and run through that whole process and kind of get that out of the way as quickly as we can. And then the contracting officers start negotiating. That process typically takes around 100. Normally, I would say 90 days for the contracting. I tacked another 10 days or so on just for some of that administrative stuff. So that puts you somewhere in August, as YK mentioned. So for eligibility, anyone can submit a proposal against the BAA. There's no classified parts of the program per se. So anyone can submit a proposal. The only thing is you have to be mindful of sort of the ground rules that are in that solicitation. Like I mentioned, for any parts that happen to be 6.3, you just need to make sure that if you're going to submit a proposal against that area, that you're able to work to the rules that go with that, right? Restricted research, it's not fundamental, there are going to be pre-publication restrictions. Just make sure that you can play in that space. Other than that, anyone can submit a proposal. That includes foreign organizations as well. That also includes FFRDCs and government organizations, which is quite often for our programs that we'll get those kind of organizations coming in as either primes, a lot of the times as subcontractors. So if those folks come to you and want a team, it's perfectly okay. They have some responsibilities, and those organizations know those responsibilities. But if you're a prime and you have one of those organizations below you, as a prime, it becomes your responsibility to make sure that those boxes are checked in your proposal, such as for FFRDC's a sponsor letter, right? So that FFRDC is handled by a government organization under a contract. There's a contracting officer. That contracting officer signs a letter that basically says that FFRDC is allowed to submit or participate in that competitive process, right? Because there's direct competition restrictions that contracting officer has to be mindful, because those FFRDCs are primarily serving a role for the DoD for a certain reason. Actually, not just the DoD, the federal government. So just keep that in mind. If you happen to team up with an FFRDC, for example, especially FFRDCs, please don't let anyone convince you that there are parts of the proposal that they don't have to give you as a prime that you don't have to give us. It all needs to be there, right? So that includes the costing information if there's an FFRDC. So please don't let that organization tell you otherwise, because that's going to put you in a disadvantage. You're going to submit a proposal, there's going to be a piece missing. That could cross the line into non-compliant, and at the very minimum, it's going to cross the line into we don't understand parts of your proposal, and likely we're not going to select you, right? Because we're going to select the ones that we truly understand. So just kind of keep that in mind. At the bottom, just make sure that you affirm or confirm in your proposal, your cover letter, that you don't have any real or perceived conflicts of interest. That typically is not a case really with the DARPA programs. We have a very clear separation of sort of church and state. We have our performer community, we have our CETA community, and we have rules in place where we do not like these two crossing, and we make it rather hard for them to cross over on the opposite sides of the fence. So, proposal abstracts. This BA has this process. Please take advantage of it. They're limited to 5 pages, I believe. I think I have up there. So it's definitely worth the time. Trust me. If we're going to put it in there, take the time to put an abstract together and make sure that you're pointed north. You truly understand what's going on in the BAA. It'll save you time later on writing a proposal that maybe is off the mark and getting frustrated later on down the road. Plus, it lets us know if there's anything going on in our BAA that maybe we didn't expect, maybe something being misinterpreted, not being understood. So definitely go through the process. When you submit an abstract, no matter what TA and what kind of performer you might be and what kind of instrument type you're going to go for, contract, grant, whatever, everybody submits their abstract to the DARPA BAA website, right? So you don't submit abstracts to grants.gov, you don't email them, you don't hand carry them. That is the only way you can get an abstract to us, so please make sure that you do that. When you submit an abstract, it goes through a process. It's not a source selection process. YK and team are looking at to see if your compass is set right and you're understanding what's going on in the program and that what you're doing generally fits within the scope of that BAA. You're going to get one of two things back in a letter. You're going to get an encourage, right, that says, go press forward, you should write a proposal, you're on track. And we may give you some feedback based on what we see in your abstract about what you should keep an eye on when you're writing your proposal. Or you'll get a letter that's a discourage, that we think based on what you've written in your abstract that it wouldn't be a good use of time and money to write a full-up proposal. We'll definitely give you a rationale for why we think it's a thumbs down so that you at least understand where we're coming from. And we may also provide feedback. It's 50-50 on those letters whether we'll give you feedback. We don't want to send mixed signals, tell you thumbs down, and then give you a list of things that lead you to believe that we want you to submit a proposal. But in some instances, we may very well do that. After we submit that letter to you for the abstracts, that's it. There's no more communications, right? They're not proposals yet. We don't do informal feedback calls. We don't set up calls and talk about them, or we would never get to the point where we're through source selection and we're off negotiating contracts and eventually getting the research done. So we make sure those letters are as informative as possible. We do a pretty good job of making sure those comments are proposal specific. I say that, and I trust in it, by the way, because we've had instances where we send out a letter, it's a discourage. We tell folks why. They actually listen to what we say. They don't dig in their heels, right? They realize what it is, where they're off the mark. They decide to write a proposal anyway. They change what they're going to do a little bit, and they actually end up getting selected. So it can actually happen where you get a discourage. You listen to the instructions, the feedback, you write a proposal. It's a good proposal, and you get selected. So just keep that in mind. Whatever happens with that abstract doesn't have any bearing on what you write in your proposal if you submit a proposal, right? We don't go back and look at it, see if you make corrections. The abstract phase is done. It's in the review mirror. We look at each of those proposals, and we map them to the BAA, and off we go. So, full proposal ground rules. I've shortened this up. If you've seen my presentation, I used to do a few slides, so part of my calendar year 19 is to shave some slides off my presentation. After 16 years of this, I'm starting to hear these slides in my sleep now. So just going to hit some of the high-level things. For this particular BAA, like YK mentioned, for each TA of the 3 TAs, you only write 1 TA for each proposal. So if you're writing a proposal, one of the 3 TAs, do not mix and match. You can write multiple proposals. You can write the multiple TAs, but each one is a separate, distinct proposal. Right? So that's really important. The last bullet, the tip at the bottom goes with that. Sort of stay in your swim lane, right? Don't try to merge things together and be creative, thinking that somehow that will impress us. It won't. That's going to make you non-compliant, and we're going to end up having to toss it out. So don't do that. Let's see. If you're seeking a contract or an OT, make sure that you only submit to the DARPA submission tool. That's important. Any other way, we can't actually review it. If you're seeking a grant or a cooperative agreement, currently that would be TA2. That only gets submitted to grants.gov, or if you want to, you could submit it in hard copy in mail. I don't think anyone's done that in 10 or so years, for me anyway, at DARPA. Most folks just submit those to grants.gov. That system seems to work. Just understand that grants.gov is not run by DARPA. If you have questions, you have issues, you have some glitches, don't send a question into the FAQ. We aren't going to be able to help with that. You've got to go to the grants.gov help desk at their 1-800 number and get that resolved. I will tell you, though, that there's a couple of steps when you submit to grants.gov. So whoever submits, if you're a university on your behalf, make sure they go through the entire process. It's not just like our BAA tool where it's just in and it's done. It's got a little bit of churning that it does before it actually tells you that the proposal's been submitted. So if you can get it through all of the steps, it doesn't show up, it's not being reviewed. So the other tip I have here is make sure you propose to the goals, objectives, metrics based on the TA that are in the BAA. If you have sort of a pet project that you have tried to get through other agencies, please don't try to find a way to shoehorn that into one of these TAs. That's not a good use of your time and money. Make sure you're actually tracking to what's in the BAA. If nothing else, it's going to at least assure you have a much better chance of being selected. Get a return on your investment. So a little more on full proposal preparation. So just for volume 1, so there's 2 volumes in our proposal. Volume 1 is the technical management. Volume 2 is cost. Standard across most of our BAAs. For volume 1, just be mindful of the page limitations. We only read up to the page limitation, then we just stop reading. Be mindful of the preparation instructions in the funding opportunity description section. So that first third of that BAA is under funding opportunity. It's the stuff that YK talked about, the metrics, the goals, the objectives. A lot of the PMs, even as you saw in some of YK slides under some of the charts, they'll have footnotes and things buried through that conversation that is really telling you things that YK wants to see you talk about in your proposal. So that may necessarily, it probably won't be repeated down in the specific proposal preparation instructions section, the administrative stuff. So you have to be mindful as you're going through that BAA to kind of underline those things when YK is saying your proposal should say this, should cover that, should acknowledge this. Make sure you're highlighting those things and you're weaving that into your approach, because what YK is telling you is that he's looking for those things, right? A successful proposal, at a minimum, will deal with those issues. So be sure to respond to all of the, so in the technical section in that BAA, there's probably 6 or 7 different areas that you have to talk about: statement of work, technical approach, facilities, transition, some other stuff. Make sure that you capture them all. They're all important. If you leave a couple of them out in order to fit things into your page limitations, you're just kind of submitting a proposal with one arm tied behind your back, right? It could be an issue that leads us to believe that you don't actually have your team set up and all of your ducks in a row, and then likely we're going to go find a proposal that seems more together to us. So make sure that you're covering all those things. I'm not going to go through them all, but the one I am going to just make sure that you guys go to see. The last few BAs that we put out at MTO, we've had a new section under the technical proposal that you have to talk about. It finds its way in one of the evaluation criterion as well, number 2. So just be mindful of this. This is specifically one that Bill has recently put in there, so it's something that is important to him and something that's important to the agency. As the DoD, we have a reason to exist. We want to make sure people understand that our performers understand what our goals and objectives are about at a very top level, and that you have plans, approaches, even from a transition perspective, that play into those things. So that particular part is making sure that we see that you are sensitive to it and understand it and have a plan that deals with that issue. Volume 2, no page limitations for the cost proposal, so you can go crazy, right? You can never say too much. You can say it in a disorganized fashion, which works against you, but put everything that you need to have in there, prime and subcontracting. You need not hold back in your cost proposal. However, do not use your cost proposal as a way to take care of the pages you can't fit in your tech proposal. We'll catch that, right? We've been around a few years, most of us. So when we do our quality check up front, we'll check for those kinds of things. So please don't do that. So YK mentioned for TA1A and TA1B, a lot of collaboration, right? The only way this program works in that area is that there is information passing back and forth between those particular teams. It has to pass back freely, it has to pass back quickly, and it can't be in sort of a reserved, held back kind of way. So the way that we do that, because those performers are going to be under their own prime contracts or under their own contracts, is we find a way to sort of connect them so that they're at least collaborating, or they're at least confirming that they're going to collaborate. And the way that we do that are through associate contractor agreements, ACAs. MTO's been using these for the last 2 or 3 years a lot. So probably 50% of our BAAs you're going to start seeing, or you've seen these in the past, and you'll likely continue to see them. So it's to connect people who are not already contractually connected, to make sure that what they're doing is agreeing that they will share information. So the best way you can sort of put it in your head is it looks and feels like an NDA, but it doesn't serve the same purpose. An NDA is all about protecting data, where you store data, how you mark data, IP stuff. You can have that kind of stuff in an ACA, but the ACA's job is supposed to show that performer A and performer B agree to pass certain kinds of information back and forth, right? The government doesn't sign that agreement. We get copies of it, put it in the file, make sure that everybody's playing by the ground rules, and only pull it out of the file if somebody's misbehaving. It's between the performers, the TA1As and the TA1Bs, all of them. So there's a lot of that that's going to be going on. For the folks that have to put that together, they're in one of those 2 TAs. You have from when you get your selection letter to when we are done with negotiations and we're ready to award. So you get that 100 days or so to get those things in place. So obviously the selection letter isn't going to tell you everything you need to know. Soon after that selection letter gets to you, you're going to get an email from the contracting officer, whoever it happens to be, and they are going to tell you who all the folks are that you have to connect with and get an ACA in place. We'll give you their names, numbers, emails, all that kind of stuff, and you've got your 100 days to go out and take care of it. I've seen these things done pretty quickly. Most of the time they're usually done within 45 days or so. Very rarely do I have them hanging around till when we're doing award. but we usually stick to that ground rule. We want to make sure folks are able to pass information back and forth before we start the first day of the program, right? We don't want to go to kickoff or get a quarterly report and find out that there are still teams still trying to talk to each other. So just make sure the legal folks are on board with getting those things worked quickly. And by the way, like I mentioned, the government doesn't sign that, right? That's between the performers. So there are other types of instruments that you will likely sign between yourselves, at least in those two first TAs, when you're kind of hooking up with the foundries, traditional stuff, NDAs to the extent they're necessary, design license agreements, like things to make sure that you're getting your hands on PDKs from the foundries, that type of stuff. You're on your own as a prime contractor, each team, to get those things in place. We expect you to do that. We don't need copies of those. You saw that in the schedule that YK put up there. You're on the hook to just make sure you get those things in place so that the commercial types of data you can get your hands on. From a proposal preparation point of view, the last bullet, on page 12 of the BAA, just be mindful, once again, pull out the highlighter that YK's asked for sort of coordination plans from TA1A and TA1B proposers. So make sure that you are giving him what he wants and make sure that you're laying out the coordination. He's kind of given you some hints in that discussion of, for each TA, what he's actually looking for in terms of the coordination that would take place. So whether it's with the foundries, PDKs, MPWs, whatever it happens to be, make sure that you're writing that down in your proposal so that YK can believe that you know all the strings that you have to actually pull and who you need to coordinate with and across the schedule when you need to make that happen. And YK gave a lot of that detail in his schedule slides, so you've got a good Cliff Note version to go by. So data rights, all that we ask is that in your proposal that you tell us if there are any restrictions on any of the data or software that you're going to be producing under your project, and for the contract folks that you're going to be delivering to us. So we have a format in the BAA that we ask folks to do. For those doing procurement contracts, it's required. It's hooked to a DFAR clause, so there's a certification process that you actually fill out. I just recommend that everyone uses that. It's the easiest way to communicate to us DoD folks. It has the right information that we're looking for, like I have on the slide, where you can identify and justify and tell us what kind of restrictions you want. We have an extra box in ours that's different than the DFARs, where we actually want you to sort of tell us why that restriction is what it is. When we're going through source selection, it helps us understand what you're thinking about. Why would you bring that technology to bear on this project if it might appear, right, at face value to be posing a barrier to transition? So it gives you a chance to make sure we understand, if I've got 2 or 3 things in there that have some kind of restriction, here's why I'm using those things, right, and why they're important on the program, but why it's okay for there to be a restriction. So you're communicating with us why we should feel comfortable with those restrictions, so take advantage of that. If you happen to be somebody asking for an OT, there are some backup slides that you can go through. There's also information on the ERI website, and you can always contact me directly to talk about OTs. When it comes to data rights, the way that we've been doing this, and it works out really well, is when you are building for your OT a milestone plan, which is the way that you get paid, right? You'll describe your milestone, your exit criteria, your due date, how much money gets paid, those kinds of things. That's a good place when you're thinking about that, when you're defining your data deliverables, to start thinking about what kind of restrictions would I want to put in place, if any. None is actually okay. What restrictions would I put on place for each one of those deliverables? And that is a good place if you're asking for an OT to communicate to that to us. Even if not using the data rights cert I mentioned, that's a good cheaty way to do it, right? So for each one of those deliverables, you can tell us whether there's certain kinds of restrictions. The thing that I ask for, if you're an OT performer especially, one of the non-traditionals, maybe TA1A, is that when you're writing those deliverables and you're mapping them back to the scope of work, keep in mind, what is the government has wants and needs, right? We have goals and objectives. There's things we want to do. There's a transition path we want to take. Some of that you're actually proposing. So make sure if you have restrictions that they are meshing with the goals and objectives of the program, and they don't create a barrier that prevents us from getting access to the data or the technology that we need. So you just have to be smart about that. Just going through and having the lawyers mark everything restricted, 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 restricted takes the least amount of time. It seems simplest, but that's not going to mesh with your own approach or a transition strategy that's at all interesting to YK and team. So just be mindful of that. For team music specifically, I don't normally do this, but the reason I put this up here is mostly for the TA1A guys, or the foundry guys, not to freak that community out. I wanted to make sure that that group understands that proposals that come in with restrictions, maybe even with lots of restrictions, especially in that particular swim lane, it's not a bad thing. We're willing to accept majority of those proposals having limited rights, but be mindful, even if you're in that space, that there may be areas of what you do. So if you're doing sort of more foundry work in TA1A, but you're also, in order to put that to practice, to prove it out, doing, let's say, DoD specific designs, maybe those designs are things that can have less restrictions or no restrictions, but we understand the things that are closer to what you do, your core business proposition, which is sort of your PDKs and that kind of thing, those are the things that are going to have restrictions. So even in that particular TA, just be mindful, it doesn't mean that you just sort of sweep across the entire thing and say restricted. Look at your scope, look at what you're doing, be mindful of what it is that the government needs from deliverables and what we're going to do with them. For the other TAs, at a minimum, we want government purpose rights so that we can do the things that we need to do. But once again, if there are any restrictions, just mark them down. So a few pitfalls, things that get people in trouble. I'll stop putting this slide up when people stop doing one or more of these things with every BAA. So far, I'm not sure that I've had a BAA where one of these hasn't come up. So we'll try to make this the one. So a failure to submit a proposal on time, right? It's like showing up to an interview late. Just don't do it. So, and I put this on the PIs. As you see in red throughout this slide, I've started adding this. At the end of the day, this is on the PIs, right? You're spending your company's money, writing your proposal, putting together your team. It's really important to you. You have something you want to do. It's on you from tip to tail. So don't just throw it on somebody's desk at the end of the process and hope to God that person got it into the system and pushed it off. You sit behind them and stalk them and make sure that it goes through so that you can sleep knowing that it went through. For some of the BAs like this one, there's what we call a second round. It's sort of a cushion. So you have that initial proposal due date. That is the only one really that I would like you to pay attention to. So for a few weeks, there's sort of a capture date afterwards where the BA is still alive. Proposals that come in after that date may be reviewed by the government. It's up to us, and it also depends on whether there's any funding left after we go through the ones that maybe showed up on time. So I would put that out of your mind. That's like a nuclear option if necessary. I would just ignore it, get stuff in on time, and you're going to be able to at least control as much of your destiny as you can. Failure to submit using the correct mechanism, like I mentioned, if you're going to come in for an assistance instrument and a TA that allows for it, you use grants.gov. If you're submitting for one of the other ones, then you have to submit it through the DARPA BAA website. So make sure that you're following that. If you submit to the wrong one, there's nothing that I can do to fix that, right? The only way you could fix it if you get caught is you have that little cushion like I just mentioned, and now your proposal gets set into sort of the penalty box, and you sort of wait till the first round to run its course. Failure to submit both volumes, of course, right? We can't review with half the information missing, so that should be obviously non-compliant. Like I mentioned, there are page limitations for the technical volume. If it's 30 pages, I can't remember what it is, and you submit 35, YK&T will never see those last 5 pages because the coordinator and I will take them off before they get distributed to the team. So if you do that, they're just going to be reading along, and all of a sudden a sentence is just going to stop. So don't do that. For subcontracts, be mindful. One, make sure you include all the subcontract information that's required to be in there. This still gets people into trouble. Primes try to submit ROMs. Primes try to tell us they didn't have enough time to get their subcontract proposal. So, here's my proposal. Please do what you can, government. Don't do those things. It all needs to be there. Prime and subcontract proposals, tech and cost all need to be there. The only thing that a subcontractor can hold back from a prime is the proprietary data. So typically what happens is there's sort of 2 versions. The version that the prime gets might be the one that uses wrap rates. So you're not going to see maybe the G&A, the fringe, those indirect rates, the labor rates. You're just going to sort of see number of hours by labor categories with just a wrapped rate. But you should still get a full up cost proposal with Excel spreadsheets by task across time with all those cost elements. Right? That's when you want to look for as a prime to make sure that's there. Once again, if we don't understand and we don't see those details for the subs, you've done yourself no favor. And definitely do not submit ROMs. So a little bit on communications. Obviously at this point, the solicitation's on the street, so the way that we primarily communicate are through these kinds of events, and we use our frequently asked question process. We do that just to make sure we control what's coming in and what messages that we're sending out, and that we're not accidentally sending mixed messages. So that's primarily how we take care of that. Once the proposals are in, things start to tighten up a little bit, and the communication lane at that point is pretty much just to that email address. So you might see an email come from the BAA coordinator that's been reviewed and approved by me when your proposal's already been submitted. That's usually a clarification request. So I'm pretty liberal in this process with BAAs, letting the team come to me if there's something that doesn't make sense, something that looks like it's missing or not legible or messed up in the proposal, whatever. If I can ask the question in a way that you can respond back without a revision or a change to your proposal, I'll typically let that thing fly so that you guys can respond back. I usually give 24 to 48 hours, right, to make sure that we truly keep it a clarification and not an amendment. I give very little time, right? You should be able to very quickly answer that clarification question and get the information back to us so the team can continue on schedule. So that's how you'll see that. Once you've received your selection letter, if you've received one and now you're off running, the negotiations are coordinated by the contracting officers, like I mentioned at the beginning. So they're going to lead that process. You might get some coordination with the contracting officer's representative and maybe from YK as we work through issues like fine-tuning the statement of work, or maybe we try to resolve some of the issues wrapped around the data rights restrictions that maybe were included in your proposal. But primarily, it's going to be to the contracting shop. Post-selection, anybody and everybody, including those who get selected or partially selected, can ask for an informal feedback session. Just like it's titled, it is not a debrief. We don't operate that part of the FAR. It is an informal feedback session. So it is 10 to 15 minutes on the phone, PI on one end, PM on the other end. DARPA PM takes you through strengths, weaknesses, deficiencies, lets you know what you liked and didn't like about the proposal. Obviously important for somebody who's not selected to kind of know where they missed the mark and how they can set themselves up to make sure that they're successful in future BAAs. So the one thing we want to make sure that you guys understand is during that session, and a lot of times I don't attend those because I don't want contracting and legal folks to attend, because then it starts to look less like an informal feedback session and more like a debrief, which I don't want. So that's why I keep it PI and PM. We don't talk about other proposals, other proposers. We don't talk about how many came in and how many got selected. So please use the little time that you have to not ask those questions. We're not going to talk about each other during that process. You wouldn't like it if we were talking about what we didn't like about your proposal with one of your competitors. So we don't do that to anybody. We stay in our swim lane, which is why we keep them to 10 or 15 minutes. So I have backup slides. I'm not going to go through. There's anybody who's new, is a non-traditional, who's thinking about an other transaction, which you can do. There's instructions, there's links actually in the BAA that'll take you to places where you can actually get some information. I've got them in this backup stuff as well. And you can kind of go through it and get a sense for maybe what you understand and don't understand if you're going to go down that path. You can always send an email to the email address in the BAA if you want to have a phone call with me to talk about the OTs. I'd be happy to do that. And we can make sure that you at least understand what they are, what the types are, and which ones you would likely fit in based on the nature of your intended proposed approach, and more important, the kind of organization that you are. And that's it. Good luck. If you have any questions, put them in your note cards.
Can I ask a question?
YK, it's up to you. Question now? Fire.
So this specifically relates to university research in 6.3, since this is a little bit new. I understand that one can use non-US citizens as students. It was clear in your notes, and that we know that the PDKs, and we have worked with the companies, the PDKs can be under NDA and can be export controlled, and we put them behind behind servers, and we know how to do our job. But it's mostly on the publication restrictions. What does, since we have not done 6.3, what does 6.3 entail in publication restrictions?
So it entails that everything you work on, every tier and everything you do is considered restricted, right? So that's sweeping. So it's not bits and pieces of information. We don't try to carve it out. Everything on a 6.3 funded effort is considered restricted, non-fundamental, which means that those contracts, those instruments will have pre-publication requirements in them.
So who approves? Is it the company or is it DARPA that approves the publication?
So DARPA, there's a DISTAR process in all of our awards. There's an email address. You send that information through a DARPA DISTAR. There's a group. It gets back. Ultimately, it always gets back to the PM, and then we decide if there's anything in there that's export controlled or overly sensitive, or maybe a mixed or bad message about our program, and then we try to get those back as quickly as we can, and then give the approval. But it does.
For sub-Gabrielle, you're going to have to go through the prompt.
Yes.
Yeah, the submission, you always can publish, but has to submit through the prime. The submission has to be submitted through the prime, and then prime will submit to this staff for approval.
And
But you can publish. So.
And TA1B, you do not want universities to lead. It has to be through a company.
Well, it has to be anyone who can deal with that kind of money. So, can a university propose? There actually are universities who can comfortably operate in the 6-3 environment. They've set up the procedures. They know how to operate it. They know what kind of people can be on and what people can't. So you can submit a proposal, right, and be a university. You just have to be mindful of there are restrictions that now you have to follow. Some schools are comfortable in that space. Some are not. So I will tell you this: no promises or anything, but. We'll kind of go through and do one last check in the next day or so just to make sure we're as comfortable as we were over the last few weeks with TA2 being 6-3. So like I said, always keep an eye out for amendments. If we decide for some reason that we've changed our mind, and I'm not promising that we will, right, follow the BAA as it's currently written, then we may change the parts of the BAA to relax that down to maybe a combo of 6-2, 6-3, which means that that's going to sprinkle throughout other parts of the BAA. Like I said, not a promise, don't expect, but we'll certainly go back and take a look. I know that Bill wanted to do that, so there's at least a small chance that it could happen. So. TA1B.
TA2 is 6.2.
Yeah, all these TAs. I just came off 2 weeks of holiday break. I'm surprised I can speak clear. My brain's still on the couch watching bad television. So, all right, any other questions? All right, good luck.
All right, thank you. So let's take about 10 minutes break, and if you need any questions, then please fill in the index card and give to Katie and in the front. The questions? Those are redundant. Okay, so maybe we can get started. So yeah, thanks for coming again, and thank you for the questions. So I try to answer at this time. And if you have other questions, please feel free to submit online on the FAQ on the proposal. The first question is, do we need to have a Tier 1A and a Tier 1B relationship established at the proposal submission? The question is, you are encouraged, but not necessary, because we really don't know which performer will be selected either in Tier 1A or Tier 1B. So basically, you are welcome to communicate, but not necessary to establish the relationship. But once we get a selection, as Michael Blackstone said, after we made a selection and send out letter, before contracting, and he will inform all the selected partner to let them know who will be Tier 1A and the Tier 1B performer would be. Then you will establish the ACA before the contracting process. So there will be good amount of time for you to establish the relationship again at that time as well. So second question is, do Tier 1B need to perform all the 3 test circuits? Yes, those are 3 benchmark circuits, and so that's required for the Tier 1B performer, and which is really important to work with the circuit topology, and also look into the fundamental elements which you would like to insert into the Tier 1A test cell, and all the PCMs on their short loop iterations. Okay, for the Tier 1A question, for phase 1, phase 2, we'll have short loop and the full MPW runs, and yes, they will be running in parallel, so they will be need to budget, because we, as you can see in the timeline, the Tier 1A will develop the process in each phase while provide the MPW on the previous generation process for Tier 1B to do. So Tier 1A performer will perform both short loop things for develop new technology, as well as provide the MPW for the Tier 1B performer. So the presentation will be available on the line. So on the Tier 1B question, the PDK will be available at the beginning of the phase 3. So as you can see, the PDK is developed in the previous generation, and then will be released at the beginning of the generation. But then for the phase 3, the 22 nanometer will be in the process integration, might not be ready to be released. So maybe at the beginning of phase 3, the PDK is still from the technology developed in the PDK in the phase 2 technology. Yeah. So in the Tier 1B question, yeah, so basically it's similar question as I mentioned before, in terms of we have to do all 3 circuits, etc. So you are also welcome to add your own particular circuit to show the super duper topology or the performance by Tier 1A tier 1B performer as well, if the reticle area is allowed. So tier 1B question, what's the meaning in the metric table between the demo and the measurement? So basically we mean the sensing. So basically you like to design, implement, and then measure the data. And also the IP cell on the tier 1B developed particularly for those 3 elementary building blocks. They will be tested by AFRL, and the AFRL will, at the beginning of the phase, will coordinate the testing plan, and for example, the input-output paths and things like that. So they will do some testing, and those IP cells developed will be deposit share in the building block cells will be depository by the AFRL. So they including some of the design, the topology and the simulation and the test data, etc. So for tier 1B question, for the PLL target at the 30 gigahertz, what's the target tuning range? Basically, it's ready to check the phase noise performance. So definitely it's performer proposed the tuning range. Certainly, we would like to have full range synthesizer, like a key size from DC to 60 gigahertz on single chip. But otherwise, we can just look at the elementary 30 gigahertz PLL and just to make sure you have a closing phase noise to meet the spec. Certainly, we trust in you that once you do that, you will be able to build a good broadband synthesizer in other cases or applications. So tier 1B questions, the divider should be static or dynamic, so we prefer static performance. So certainly you can try dynamic divider as well. So tier 1B questions regarding the ADC, and again, the question on the phase 1, we have a relatively low frequency ADC, but a very high in-up. As I mentioned before, the whole goal of the converter should be geared toward the phase 3 target. But the phase 3 target, definitely you might need some sub-ADC, which you might be able to build in the phase 1. But to push the boundary a little bit more, so we get to get a 16 bits rather than just 12 bits and that kind of things. So they make sure we will take care of some of the phase margin and the timing jitter and some of the other things. So that's particularly for the phase 1 thing. So you can use that to build up the sub-ADs for the later phases. There are also other applications. We are very interested in the 1 giga sample 16-bit things. There are many applications can be used. So that'll be a good contribution if we can implement that. So tier 2 question is the monolithic 3-5 integration of 200, 300 millimeter wafer okay? Certainly we don't like to have discrete 3-5 devices deposited on the 200 millimeter wafer or fully processed 3-5 devices bonded on the silicon wafer. But we encourage the exploration if the 3-5 material, just like other ferroelectric material or the germanium material, can be incorporated in the traditional silicon process flow, that will be encouraged. So basically, we like to develop a wafer scale process for the future. So definitely different material things, if you think it can be incorporated in the 300 millimeter, 200 millimeter process flow in the foundry or the traditional silicon processing flow, will be very welcome. I know a lot of people are working on some of these devices too. So tier 2 question is FT more important than the Fmax? I think we specify both FT and the Fmax. So certainly for certain application you can optimize one versus another, but we have a basic requirement in the matrix. So certainly if one of them or both of them beyond the matrix number will be greatly appreciated, but definitely we like to see a balanced FT and the max, which make the circuit design much more easy and than just very on one side. Okay, so is the TA2 effort bipolar only process? No. Basically, as the example show, we can look into both FET and the bipolar or other devices, as long as you can provide a performance like what we expected in the matrix, will be very welcome. Okay, so some of the baseline measurement will be good to support those matrix data. So definitely, we very pleased to have AFR and other government agency to support us on some of the testing. Basically, AFR is mainly will be the testing hub, and at the kickoff meeting, they will be working with you to provide some of the test plan and structures. Yeah. Okay, so that's pretty much the question I have so far. So any other questions? Yes?
I didn't quite understand the IP repository thing still. So are you guys saying that our designs would go into this repository and anybody can use it? What exactly is meant by that?
Yeah, so the IP repository, and we would like to, AFR have some kind of design center, and they try to build up a repository. So right now we are trying to collect the basic testing cell elements, right? So like those test circuits is not particularly application specific, right? So, but they will be able to be deposited as a reference, so people will be able to access it. Yeah.
So I guess that was the question. Would our competitors, for example, be able to use these circuits?
So again, they will be going to the IP rights and that things. I think definitely we appreciate the competitive needs. Definitely we will keep this under certain things. If you can specify, yeah. Yeah. Okay. Yes, Gabriel.
I do not understand in the schedule how we can design circuits in TA1B if the devices and the PDKs and are not yet there. So are we supposed to be designing them and making proof of concepts on, for example, GlobalFoundries 9HP or S5 in Tower Jazz, or are they going to very quickly within 6 months, 9 months make a new transistor and a new PDK and we can use it? The design
Understood.
aspect
Okay.
has to lag like 1 year from the device development aspect.
Yeah, understood. So repeat the question. So the question is for the Tier 1B designer, will they have enough time to use the new transistor technology? As I mentioned before, for each phase, the Tier 1B designer will use the PDK available already existing. So basically, there are already existing foundry processes available. So for the phase 1, you can use that. I think that's available. And then after 18 months, they will publish the updated PDK. Then in the Tier 1B phase 2 design, we'll use the phase 1 technology and publish at the beginning of the phase 2 for design. So I allocated about 4 months-ish or 5 months design cycle before the taping, right? So then the cycle time is about 5-6 months. So I try to fit into the 18 months time frame. So there should be a reasonable time to do that. And the PDK should be ready at the beginning of each phase.
So therefore, phase 1 designs are based on current technology.
That's correct. Yeah. So if you can read the table, I say PDK 0. That's the existing published thing. Yes.
You answered partially for the ADC phase 1. You list one biggest sample, but you list the bandwidth. You suggested that the bandwidth could be 100 megahertz. So could you maybe just state specifically what the metric there is?
Okay. So I can, yeah, that's I cannot leave it vague. It's up to performer to define, but we prefer to be 100 mega, 200 megahertz for some of the good application for DoD. So if one, we can amend some of these things to our matrix table. Yeah.
Given that the goal for the FTF max was 350, 500 for phase for the first application, do you recommend that in the first design, like Gabriel was asking, that you use a particular technology that would be close to that goal, like IBM 9HP?
Well, that was the end of phase goal in certain one in that matrix at the end of phase 1. The problem in the phase 1 for TA1A, the question is what kind of FTF max in the phase 1 for 350 or 500 will be available for Tier 1B designer, but the for phase 1, the Tier 1A will play with their short loop things for the prepare for the phase 2 technology, right? So, and also for new integration scheme for the advanced CMOS, which they will do a independent task. But to support the MPW was for phase 1 was from the existing foundry platform. That's why the Tier 1B, like Gabriel say, can start design right away without waiting the whole 18 months to get new transistor, characterize, PDK published. So that will be for the phase 2. So for phase 1 will be existing process. Yeah. Okay, so if not questions, then you can always send a question through the website, and I appreciate you coming here. And Happy New Year, and looking forward to your great proposals. Yeah. Thank you.